Okay, so now we're going to practice adding and subtracting. Adding or subtracting, the rules are the same, roots. So what we remember from class the other day is these are very much like terms to be able to combine. So for example, thought bubble, something like this, we can combine to give us this. But something like this does not give us x, y, or any combination, okay? These cannot be combined because they're not like terms. So right now, the form we have these in, they are not like terms. 18 and 2 are not the same. So we're going to go exploring. We're going to think about how can I simplify? Well, 2 can't be simplified, but let's take this off to the side and let's think about 18. Two numbers that multiply to give me 18 are 9 and 2, and 9 breaks down into 3 and 3, okay? And so this means the square root of 3 times 3 times 2 gives me the square root of 18. I have a pair. Where there's a pair, there's a square. And so I get root 9 times root 2, and that gives me 3 root 2. Okay, so now what I'm going to do is I'm going to sub that in right there. So 3 root 2 plus 3 root 2. Okay, and remember, if you're wondering where did all that come from, remember, this is the same as saying this is the same as saying this. Okay, so we can plug those in. We kind of plucked out the root 18 and we plucked in the 3 root 2. So now if I think about 3 times 3 root 2, that's all those parentheses really mean. I can multiply the things on the outside, which gives me 9 root 2. Okay, so this is 9 root 2 plus 3 root 2. Now, we go back and we say, can I combine these? The answer is yes, because these glorious things are the same. Okay, so I've got 9 of them and 3 of them. I think about how many then do I have? If I have 9 root 2s or 9 apples plus 3 apples, I'm going to have 12 apples. Here's my answer. And again, I can always plug this into the calculator and then this into the calculator. And if I get the same nasty decimal, it's correct. Okay. Here's the second problem in this video, and the last type of problem we did. So we did rationalizing the denominator. So rationalizing the denominator means get rid of the radical. Now a number could be down there, okay? Let's even put one there. Let's do that, okay? Number can be there, but rationalizing the denominator is still the same regardless. So just because there's a 2 down there doesn't mean I do anything differently than if there was just a root 3. I need to get rid of that root 3, and so to get rid of the root 3, I multiply the top and the bottom by what I want to get rid of. Up here I get 9 root 3. This is outside the root, this is inside the root, therefore I can't really do much. Down here, I have 2 times root 3 times root 3. And that's going to give me 9 root 3 on top over 2 root 9. And then if I simplify it more, I get 9 root 3 over 2 times 3. Again, where did that 3 come from? Root 9 is the same as 3. And everything else kind of stayed the same. Now I look at this and I think, okay, what can I do? Well, I could probably combine those. That's one way to think of it. So 9 root 3 over 6. This is the same as saying 9 over 6 times root 3. 9 sixths as a fraction can be simplified, and the number that goes into both of those is 3. So I can divide the top and the bottom by 3, and I get 3 root 3 over 2. That's my answer. Now you might have noticed that here, which is kind of nice. What you might have noticed is if I have 9 root 3 over 2 times 3, This is really the same as 9 over 2 times 3, and then that root 3 is kind of hanging. 3 goes into 9 3 times, and then that gives me the same answer a little quicker. Now, the good news is this is the same thing. To rationalize the denominator, you need to get rid of the radical in the denominator. Notice we still have one up top, right? You can't get rid of it completely. You also have to simplify radicals, right? If we created something up top that needed simplifying, we'd have to do that. And you also have to simplify fractions.